Congratulations, you made it to the homework assignment for day 5. Look how full of knowledge your head has become in just 5 short days. And we're going to prove that your head is full of knowledge because this is a challenging exercise. Okay, so the bad news, let's set up the scenario, just like we always do. The bad news is that the Rung was shut down, that spy agency that you worked for previously. The good news is that it wasn't your fault and you were not indicted. So you move on, and this time you work for a government program called the MRU that keeps track of citizens that have, how shall we say, special powers, sometimes referred to as mutants. You join a team that's designing an application to analyze mutants. And so the team has designed a UML diagram of what they want you to code up. So in this particular case, you can see there are some important features. First of all, we have a mutant class that's abstract, and it supports an abstract method called danger quotient. We'll come back to that in just a moment. And then we have 3 classes that derive from that parent class mutant. A psychic mutant, a physical mutant, and an elemental mutant that all extend that base class in their own specific ways. So you'll work with a collection of mutant records, and you're going to need to write a routine that will iterate through each mutant record in the collection and analyze that data to determine their threat level. To determine the threat level, each type of mutant has a danger quotient. So psychic mutants, their danger quotient is the level times their IQ times the documented count of uses of their power. So if you look at the psychic mutant, it's going to be the level, which is inherited from mutant, the IQ, which is specialized, a public property for psychic mutant, and then also the usage count, which is specialized to the psychic mutant. Physical mutant's danger quotient is calculated by taking the level, again, which comes from the mutant base class, the IQ, which comes from the physical mutant class, and then the strength property, which comes from the mutant class, or the physical mutant class. All right, and then finally, the elemental mutant's danger quotient is simply the level, which again comes from the mutant base class, and then also multiplied by the region, which is just 1, 2, 3, 4, 5, something simple like that. Okay, so each instance of the mutant class will derive from an abstract base class called mutant. That much is obvious. So you're going to create at least, 4 classes there? But in addition to that, in order for your application to work with existing code that was created prior to your arrival here at the MRU, you are going to need to implement a custom interface. So all of your classes must implement the iDisplayable interface, as you can see here on the right-hand side of the diagram. So that requires you to implement a single method called display information. To implement this, you should use a simple console.writeLine and use the danger quotient. You can format it somehow to look good. Okay, using that console.writeLine with the special formatting string.format syntax that you saw, or just with the curly braces and the 0, curly braces 1, curly braces 2, you can use that. Okay, see if you can figure that out on your own. All right, so finally you should be able to create in your in the program.cs some code to test out this application. So you should be able to create 2 of each type of mutant. You must add them to the collection, fill out all of their properties, and then iterate through them using the iDisplayable interface's display information method on each one of them. So I want you to do this using a generic collection and a for each statement. Okay, so hopefully you listen to those instructions carefully. Notice one thing, that the interface is being implemented by the mutant class, by the base class, and then by virtue of the fact that that it's implementing that display info method is available to each of the derived classes. Okay, so hopefully that gives you enough information. Here's the ultimate output of the application as I built it. So we get the name of the mutant, the code name, and then DQ, danger quotient, and then whatever that calculation comes out to be based on the type of mutant that we're dealing with here. Okay? So I threw a lot of requirements out at you. I'm going to create a requirements document for this as well so you can reference that. If you have any questions, again, you can take a look at the solution, but try to struggle with this on your own. You might be able to implement this purely, at least most of it, purely from just looking at this diagram. But then also you might need some of that additional information we talked about with regards to how to calculate that danger quotient for each of the 3 derived versions of the mutant base class. Okay, so give it a try. See how you do. Might take you 15 minutes, might take you a half hour, but work on it and see what you come up with. We'll see you in the solution video. Good luck. See you there. Bye.